Some of the most important AI models in the world are now coming out of China. And instead of keeping everything behind a private API, companies like DeepSeek, Alibaba, and Moonshot AI are releasing models that people can download, modify, and run themselves. You will see these models described as open source all the time, but in many cases, open weight is the more accurate term, and the difference matters if you want to know what you can actually do with the model. My name is Christian, and on this channel, I test and simplify new AI tools so you can understand what actually matters without wasting hours figuring it out yourself. So let's lock in for the next 10 minutes. I'm going to explain open source versus open weight in plain English, show you where models like DeepSeek, Qwen, and Kimi fit, and give you 3 questions you can use to evaluate any AI release. The easiest way to understand this is to start with a completely closed model. When you use a closed model, you normally interact with it through a website, an app, or an API. You can type a prompt and receive an answer, but the company keeps the actual model on its own servers. You cannot download the model itself. You cannot independently run it. You can't modify the underlying model or redistribute your own version. And if the company changes its price, removes a feature, changes its safety rules, or shuts down access in your region, you have to live with that decision. It is like ordering a meal in a restaurant. You can eat what they serve, but you do not receive the kitchen, the recipe, or the ingredients. That does not make closed models bad. A hosted service can be far easier to use, and you do not have to buy GPUs or maintain infrastructure. But you are receiving access to a product, not ownership or control of the underlying model. The next step is understanding what model weights actually are. When an AI model is trained, it processes huge amounts of data and repeatedly adjusts billions, and now sometimes trillions of numerical values. Those learned values are called parameters. And the largest part of those parameters are the model's weights. The weights help determine how the model responds to your input. They contain the statistical patterns the model learned during training, but they are not source code in the traditional sense. You cannot open a weight file, scroll to line 4000, and find the rule that makes the model write a poem or refuse a request. You are looking at an enormous collection of numbers, not a readable list of facts and decisions. Returning to the restaurant analogy, the weights are the finished meal. They are the result of the ingredients, recipe, equipment, and cooking process, but they do not automatically tell you exactly how the original kitchen produced it. An open weight release gives you access to that finished set of learned parameters. Depending on the license and the other files provided, that can be extremely valuable. You may be able to download the model, run it on your own computers or cloud servers, fine-tune it for a particular task, compress it, build an application around it, or create a derivative of the model. For a business, this can mean keeping private data inside its own infrastructure. For a developer, it can mean building without depending completely on one API company. For a researcher, it can mean testing the model in ways the original provider did not anticipate. But the phrase open weight makes a narrow promise. It tells you the parameters are available. It does not automatically promise the original training data, the reinforcement learning process, or the intermediate checkpoints that produce the final model. And it does not automatically mean you have unlimited legal rights. One open weight model might use a permissive license, such as MIT or something else. Another might prohibit certain uses, require attribution, restrict large commercial services, or require a separate agreement. So remember this. Open weights tell you what artifact was released. The license tells you what you are allowed to do with it. Open source AI is a stronger claim. The open source initiative spent years developing a definition specifically for AI because an AI system is more than ordinary software. It combines code, data, configuration, architecture, and learned parameters. Under its open source AI definition, the user must have 4 basic freedoms. The freedom to use the system for any purpose, study how it works, modify it, and share the original or a modified version. To make those freedoms meaningful, the release needs 3 major categories of material. First, the parameters, including the model weights and relevant configuration. Second, the complete code used to train and run the system. That can include the model, architecture, data processing code, and some other things. Third, detailed information about the training data, where it came from, what it contained, how it was selected, how it was labeled, and how it was filtered or processed. There is an important nuance here. This definition does not say every piece of raw training data must always be uploaded for the world to download. Medical records, private information, or copyrighted material may not be legal to redistribute, but the release still needs enough detailed information for a skilled person to understand what was used and build a substantially equivalent system. In other words, open source is not just receiving the finished meal, it is receiving the recipe, the relevant ingredient information, the preparation process, and the legal freedom to study it, change it, and serve your own version. So here is the clean comparison. With open weights, you receive the learned parameters and can usually run or adapt them, but the rest of the development process and your legal rights will vary from release to release. With open source AI, you receive the weights, the essential code, meaningful information about the data, and broad legal freedom to use, study, modify, and share the system. Every genuinely open source model needs open parameters, but an open weight model is not automatically open source. Now let's apply this to the Chinese model releases that are putting these terms in the headlines. DeepSeek R1 was one of the releases that made this conversation mainstream. DeepSeek released its model weights in repository under the permissive MIT license. That gives developers broad rights to use the weights commercially, modify them, create derivatives, and distill the model into smaller versions. That is far more open than a model available only through an API. But if we are applying the open source initiative's full standard, we still have to ask whether the release includes the complete training pipeline and sufficiently detailed information about all the data and post-training stages. An MIT label on the repository does not answer those questions by itself. Alibaba's Qwen team used a more precise language when it released Qwen 3. Its announcement said it was open weighting the models under APAC 2.0. That tells us the weights are available under a permissive license without requiring us to assume the complete original development pipeline is reproducible. And then we have Moonshot AI's Kimi K3, one of the newest and clearest examples. Moonshot describes Kimi K3 as an open weight frontier model. It has 2.8 trillion total parameters, and the model weights are available under a custom Kimi K3 license. That license gives most users broad permission to run, fine-tune, modify, and distribute the model. But it also says that certain model-as-a-service businesses with more than $20 million in revenue must reach a separate agreement with Moonshot before using it commercially. This is exactly why the terminology matters. Kimi K3 is genuinely downloadable and adaptable. It is not closed, but its custom commercial condition does not cleanly fit the OSI principle that an open source AI system must be available for any purpose without asking permission. There are also several things the word open does not tell you. Open does not mean unbiased. It does not mean safe. It does not mean uncensored. It doesn't mean accurate. It doesn't mean free to operate. Kimi K3 may be downloadable, but a 2.8 trillion parameter model still demands serious storage and compute. The simplest way to remember all of this is that AI is a spectrum. At one end, a closed API lets you use a model, but gives you very little control over it. In the middle, open weights gives you the trained parameters and potentially a huge amount of freedom to run and adapt the model. But the supporting artifacts and license can vary dramatically. And at the far end, open source AI gives you the parameters, essential code, meaningful data information, and the legal freedom to use, study, modify, and share the system. The Chinese open model wave matters because it is pushing powerful AI outside closed platforms and giving the rest of the industry more options. We don't need to exaggerate that achievement by treating every kind of openness as identical. So when you see the next open model announcement, check the artifacts, check the license, and be precise about what is actually open. If you enjoyed this, please subscribe to the channel. I'm coming out with new videos just like this every week. Thanks for watching. I hope to see you in the next one. Thank you.